couple different types of correlation, and a correlation measures the strength of an association between two variables, so just two variables. A Pearson correlation coefficient measures a linear correlation, again a parametric test. Should be used when you've got normally distributed, Gaussian distribution, bell curve. You don't have to have hundreds of points, enough so that you can see this distribution and use this parametric test. So it's measuring a linear correlation. And in the figure here, you see how that looks for different types of associations between those two variables. So a perfect positive correlation is the left side of this figure, and all of the points, each point representing an individual in your data set, and the correlation between two different variables, those are your axes, your x and your y-axis. They're not labeled, doesn't matter what they are. Perfect correlation is they're lying right along a line, a perfect positive correlation. And then zero correlation, you just got this beautiful random distribution of spots on your figure. And on the right side, your correlation, your line going the other direction is a perfect negative correlation. So as one variable is going up, the other one's going down. A Spearman correlation measures the association between two ranked variables. So you've got order, but it's not really a continuous variable. So you might have age categories, for instance. Always order. When you collect data, oftentimes you're putting a number to it. The number may or may not make any difference in terms of order. So you do have to have order here because you're looking at the association. As one variable goes up, does the other one also go up? And then, so those were parametric tests. Now, non-parametric correlations. We have two different types. A Mann-Whitney U test and a Wilcoxon rank test. And you really will see these quite commonly in peer-reviewed papers. So Mann-Whitney U test you have independent samples, again a non-parametric test. A Wilcoxon rank, you have dependent samples, again a non-parametric test, so that the samples, same individual. So Mann-Whitney you would use where you're comparing different groups, and a Wilcoxon if you're doing, say, a pre-post, because they're dependent. And here, love these figures because they demonstrate the clearly non-normal distribution. So this is looking at differences in a published study about from the China Health and Retirement Longitudinal Study of aging, and folks with chronic lung disease. You've got a frailty index in two different cohorts, a Charles cohort and an ELSE cohort, and the blue and the red demonstrate the distribution of the data. If you were to think about flipping them the other direction, you'd think about a tail. And if you watch the module on distributions of data, you see a big skew. So if you again tip them the other direction, you'll see that they're skewed to the left with a long tail, which means you need a non-parametric test, which you see here.